Hello, and thank you for clicking on this video. This is going to function as kind of a basic overview of pollination, specifically looking at some of the adaptations that both pollinating insects and the flowers they pollinate have that make the whole process more effective and efficient for both. Yeah, I worked pretty hard on this, so I hope you enjoy. So, as sort of an introduction, I'd like to first talk about why an insect would want to visit a flower and why a flower would want to have an insect visit it. So, why would an insect want to visit a flower? Well, pollinators, so this is things like bees, some flies, butterflies, moths, etc. Um, Pollinators eat either pollen or nectar, in a lot of cases, both, and flowers are a really good place to get both of these. So this incentivizes insects to come to flowers, collect those resources, and then visit other flowers. And pollinators will adapt to make collecting pollen and or nectar a bit easier for them. So, why would a flower need an insect to pollinate it? Well, pollination is the main method of reproduction for a lot of species of plants. Take like an apple, for instance, right? Like that is the result of pollination. To get that apple, you need to have a bee or a butterfly or something take pollen from one flower and bring it to another flower. In which case that new flower or that second flower will be fertilized and an apple will grow in its place. And plants will adapt to reduce pollen waste and to make sure that the pollen actually makes it to another flower of the same species. So the fruit will actually, grow. So the first real example I'd like to talk about, I feel really exemplifies how both pollinators and plants adapt, and how those adaptations can influence and go hand in hand with each other. And this example is the Darwin's moth and the Darwin's orchid. Now, as you can see from the picture on the left, the Darwin's orchid has this really long structure going down from it. And this is called the spur. And at the bottom of the spur is nectar. And the Darwin's moth is pretty much the only insect that is able to drink that nectar because, as you can see, it has this absurdly long tongue or proboscis. Um, and so these are two species that have lived together for a very long time, and have adapted to each other. The Darwin's orchid has adapted so that it targets this specific moth because it knows that the Darwin's moth feeds on it and is going to visit other Darwin's orchids. So it's worth it for the orchid to adapt so that it targets the moth, and the moth is going to develop this really long tongue to be able to drink the nectar from the flower it actually visits. And when it is drinking the nectar, it's like rubbing its face up against the flower, and the part of the flower where the pollen is, and it's getting that pollen on itself. When it goes to another orchid, it's dropping that pollen off, fertilizing the orchid, and the pollination process is essentially complete. But yeah, this just goes to show how a flower and its pollinator will adapt, evolve. Oftentimes, this adaptation and evolution is influenced by each other, sometimes to striking degrees. This is a really kind of extreme example. This is one that, shocked Charles Darwin himself. I still find it to be just so fascinating how these two separate organisms, have kind of developed over time to be so well suited for each other. A lot of the examples I'll talk about here aren't necessarily as extreme as this, but it does go to show that these sort of adaptations do happen, and this example can be used to inform how we look at other plant pollinator relationships. So now I'd like to talk about some adaptations that insects in particular have that make collecting resources from flowers a bit easier for them. And I'll first talk about one of the more widely known adaptations, which is bee hair. This is also called scopa. But Scopa are these bristly little hairs that usually completely cover a bee's body. And as you can see from the pictures of bees just completely covered in pollen, they're very good at picking up pollen. And this is helpful to a bee because a lot of species of bees actually eat pollen. So it's really useful for them to have these structures which allow them to pick up a lot of pollen at once. However, it's also really helpful for the plant because the chances of a bee successfully pollinating the next flower or the next flower it goes to, um, the chances of it pollinating that flower are a lot higher if it has a lot of pollen with it versus if it just has only a few grains of pollen with it. So it's beneficial for the bee to have or to be able to carry a lot of pollen with it, but it's also beneficial for the flower if the bee is able to carry a lot of pollen. So another pretty well-known adaptation is the tongue or proboscis of a butterfly or a moth. Now I've already talked a little bit about this with the Darwin's moth. However, I think it's worth talking about it again here because a proboscis is just such a fascinating tool that allows a butterfly or a moth to collect nectar from a plant in a way that it wouldn't be able to otherwise. As you can see from the picture, these tongues are usually extremely long and narrow, allowing it to kind of get inside the plant or the flower itself and collect the nectar, which is mostly what butterflies and moths, eat. When you compare uh, the proboscis and I guess butterflies in general to bees and their scopa, they are a bit less beneficial to the flowers themselves because if you think about the scopa, they're really specially designed to transfer pollen from one place to another. Um, but a proboscis is really only useful in extracting resources from the flower. Like a butterfly isn't concerned about what happens to the pollen. Any pollen transfer is going to be a coincidence, basically. Like as the butterfly is feeding on the nectar, it's still crawling all over the flower collecting pollen on its legs or body or something and transferring that pollen to the next flower it visits. So, I guess what I'm trying to say is that it is still beneficial to a flower to have certain adaptations that will attract butterflies, even if it's not as important or as beneficial as attracting a bee might be. But there are still plants that you'll see that specialize in a certain butterfly or moth, like the Darwin's orchid, actually. So the last insect-specific adaptation that I want to talk about is probably my favorite from the section, and it's buzz pollination. I like it so much because it's just so strange and honestly kind of funny. Like it looks goofy to look at, and I don't know, I just really like it. But as you can see from the GIF, buzz pollination is when a bumblebee or some other large bee that's able to use this flies up to a flower, lands on it, and vibrates its body such that the pollen that is in the flower is dislodged and basically covers the bee. Um, and these bees have adapted this to um, get pollen that's lodged in a flower and would otherwise be very difficult to get without destroying the flower itself. And again, it's just another adaptation that allows in a bee to access resources that it otherwise wouldn't be able to. Um, but this is also somewhat of an adaptation by the flower itself because by making this pollen difficult to get, it's targeting bees that are able to use buzz pollination to get the pollen out because it knows that if a bee is able to get that pollen, it's very likely to visit another flower of the same species. And of course, when I say it knows, I mean it has adapted and evolved with these bees over a very long time and is specialized to have a relationship with that bee. That's what I mean when I say no. Um, and this actually segues pretty nicely into the flower adaptation section, and one of the strangest adaptations that I have ever heard about in the flower kingdom, which is corpse flowers. So on the left, you have a stinking corpse lily, and on the right is a Titan arum. Um, and both of these flowers, their main adaptation to attract pollinators is by stinking like rotting meat. Like you'll see videos of people interacting with these, and they'll just be saying the whole time just how awful it smells. Like it smells like rotting meat. And the purpose of this is to attract flies because flies like rotting meat. It's a place to lay their eggs. Um, and so these flowers will release this scent that attracts flies. Flies will um, land on them, crawl around them, get covered in pollen. And when they, realize that there's no actual meat there to lay their eggs on, they'll leave, be attracted to another corpse lily or Titan arum that is, releasing the same scent. And the flies will transfer the pollen from the first flower to the second, successfully pollinating it. Um, this is kind of an extreme example, a very a very strange and unique phenomenon for some very strange and unique plants. Like these are like you can see from the pictures, these are huge, bizarre looking flowers. I believe these are both native to Southeast Asia, if I'm not mistaken. Um, but this concept holds true for a lot of flowers around the world. In North America or in America, I should say, like if you go up to a flower and it smells sweet, like that's a really common thing. Like flowers smell good, and the reason flowers smell good is to attract pollinators, because a lot of pollinators are able to smell. They smell the flowers, they know that there's a meal waiting for them there, and they fly to the flower, they land on it, and do the things that I've already discussed. So yeah, with the corpse flowers, it's just an extreme example that kind of shows why a flower would use scent to attract pollinators because it's a really effective strategy. That's why so many flowers smell, whether it be good or like, rotting meat. So, to talk about the next plant adaptation, I have to first talk about how bees see the world. So, humans like you and I, we are able to see the visible light spectrum that's Roy G. Biv, like the colors of the rainbow. But bees are able to see ultraviolet light really well. And if you take a look at the picture I have shown here, the leftmost rectangle is how you and I would see the flowers that are shown. This is the flower under like normal light. In the middle is how a bee would see the flower, or at least the colors that a bee would see. And in the rightmost rectangle is a more accurate version of what a bee's vision actually looks like. Bees don't have eyes like you and I do. So instead of seeing like really defined, sharp shapes like we do, their vision is a lot more blocky and abstract, if you will. Um, and keeping that in mind, let's look at how flowers use this to their advantage. Um, so if you take a look at the pictures that I have shown here now, on the top is how these flowers look like to us. Similar to the last slide, this is just if you and I went outside and saw one of these flowers, this is how it would look. Um, and for all of these, you can see that they're pretty nondescript. They're yellow. I think they're pretty, but there's no pattern to them, is what I'm trying to get at. But if you look at the pictures on the bottom, this is those same flowers viewed under ultraviolet light, or in other words, what a bee would see, the colors that it would see at least. And as you can see, there's these really striking um, splotches of color pretty much in the center of all these flowers. This is sometimes called a bullseye pattern. But what this is it's patterns that are visible to bees that help them pinpoint where the pollen is actually located on the flower. This is basically um, a bullseye for the bee that tells them where to land on the flower and where to crawl around to actually collect the pollen. And obviously, this is going to be beneficial for the flower because it doesn't want a bee to visit it and not pick up any pollen. And it's also beneficial to the bee for the same reason because it also doesn't want to visit a flower, not pick up any pollen because they eat pollen. Um, I imagine this is also a really good way of catching a bee's attention. Like you saw in the more accurate representation of how a bee sees, its vision is very um, it's not sharp. So if a flower has a bullseye pattern in its center, I can imagine it catching a bee's eye a lot better than just a flower that doesn't have any sort of patterning at all. So I know I've been talking a lot about bees and butterflies, but I also want to stress that lots of other insects pollinate as well, as you can see here. Um, Pretty much any type of insect you can think of has a species or two that will feed on flowers and therefore pollinate. Common ones include beetles, bees and butterflies, of course, moths, wasps. There's a lot of species of wasps that pollinate. And a really important one is flies. I mentioned flies in relation to the corpse flower, um, but in the case of the corpse flower, that was more the flower tricking the flies into pollinating for it. There are types of flies called syrphid flies, usually, that, like bees, uh, feed on flowers, and they're a very important pollinator. In Western North Carolina, where I'm based, they're an extremely important pollinator. Um, but yeah, I just want to make sure that I stress that it's not just bees and butterflies that pollinate, but lots of other insects do as well. And this gets into promoting diversity, which is a whole nother topic. But yeah. Um, And so that brings me into, I guess, really my closing statements, which is this video isn't just meant to educate you on pollination, but it's also meant to encourage you to get outside and witness it for yourself. All the pictures on screen right now are pictures that I took. either around my yard or in the woods near my house. And I just want to stress how really common pollination is and how easy it is to see for yourself. So if you do want to get out there and maybe take pictures, take some notes on what you see, I highly encourage you to do that. And if you do, may I suggest joining my iNaturalist project, which I made to go along with this video. Um, the QR code is on screen right now. I'll put the link to it in the description. But essentially, iNaturalist is an app that will tell you what animal you found. Like it'll put a name to the animal you found. I love it. I use it all the time, and I made this iNaturalist project specifically so that people can put pictures of pollinators and the flowers they're pollinating in one space, see the pictures everybody else is putting there too. There's a leaderboard, which I think is pretty fun. So if you are interested in that, scan the QR code or click the link in the description and join the project. Um, Finally, here are my references. If you'd like to read more about anything I talk about in this video, I would suggest reading some of those links. They go into a lot more depth than I do. One in particular goes to like a big long list of uh, plants and their UV light patterns. There are much more examples of that I didn't include in this video, and I think it's extremely fascinating. There's a wide variety of flowers that use this strategy. Um, but yeah, thank you so much for watching. I really hope you enjoyed. I hope you learned something. Um, yeah, join my naturalist project. Thank you.